Okay, we're going to start with this problem, and we've got an equation. Now we've done problems similar to this, so hopefully this one shouldn't be too bad. Y equals negative 3x plus 2. Write that down, pause the video, come back when you have graphed it, and determine a table of values. Okay, you're back. And if you're back, that means that you have actually done this problem. Now, there are a couple of ways to do this problem. So I'm going to show you the way that I think kind of it occurs to me first. So when I look at this, I go, oh, I think the slope of this is negative 3 and the y-intercept is 2. So I'm going to begin at 2. And then because my slope is negative, I'm going to go down and to the right. So I'm going to go down 3, 1, 2, 3, and to the right 1. Down 3, 1, 2, 3, and to the right 1. Is that right? 1, 2, 3, and to the right 1. Maybe if I zoom in a little bit, that'll be easier. Down 3, 1, 2, 3, and to the right 1. I can also go up 3, 1, 2, 3, but then I have to go to the left 1. And let me just replot this point just so it really lines up. Now I can see that line. Notice how they all line up. I go down 3 to the right 1, down 3 to the right 1. All right, now I am going to draw that line in. And this is harder than it looks. Okay. Good enough, right? Now, from here, if I like, I can just look at the coordinate of each one of those points and plug it into my table. So I have negative 1, 5, and 0, 2, and 1, negative 1, and 2, negative 4, and 3, negative 7, and I didn't plot the fourth one. Now I could count down 3, 1, 2, 3 over 1 and get negative 10. Or, look at this, I could see, does it follow the pattern? Am I subtracting 3 each time? 5 minus 3 is 2. 2 minus 3 is negative 1. Negative 1 minus 3 is negative 4. Negative 4 minus 3 is negative 7. And negative 7 minus 3 is negative 10. So it fits. And what's nice about this is that we always have a way of checking our work. So that's great. Now, I said that there was another way of going about this problem. So let me show you that too. So let me just get rid of all of that stuff there. Okay, now let's say, let's say that you wanted, come on, go away. You wanted to do this problem, but you wanted to plug in points. You want to really get those points correct. Well, you can do that too. Look at this. You can plug in negative 1. If I say f of negative 1, and then I plug in negative 1, negative 3 times negative 1 plus 2. You'll remember doing this in a second. What I get is negative 3 times negative 1, positive 3 plus 2, that's 5. When x is negative 1, y is 5. When I plug in 0 into my function, I get negative 3 times 0 plus 2. Negative 3 times 0 is 0. Add 2 to that, and you should get 2. If I were to plug in 1, f of 1 equals negative 3 times 1 plus 2. I get negative 3 plus 2. I get negative 1. And you'll recognize, oh, whoa, those are all the same numbers that I got when I did it the other way. Yes, absolutely. So there's more than one way to do these problems. And I've run out of room, so I'm not going to continue to do the rest, but you can if you'd like. Let's move on to another problem. Now, this time you have a graph, and you need to come up with an equation and a table of values. And I'll zoom in on that graph for you so you can see it. This is the point over 4, up 1. And this is the point back 4, back 1. Now, pause the video and determine the equation and the table of values. Okay, you're back. And if you're back, that means you've already determined the slope and you've already determined the y-intercept. Let's take a look and see if you were right. Now, for this problem, I go from one point to the next, so I notice I rise 1 and I go to the right 4. From this point, I rise 1 and I go to the right 4, which tells me that my slope should be 1, rise 1, and go to the right 4, 1 over 4. I also notice that my y-intercept my line crosses the y-axis at 0, so my y-intercept is 0. From there, I feel pretty confident about my equation. I think my equation should be y equals 1/4 x plus 0. Now, I don't have to write that plus 0, because if I'm like, hey, I have 2 kids plus 0 kids, that would be weird. I would just say I have 2 kids. So you don't have to write plus 0, but if you do, I will not mark you wrong. Okay, now this table of values gets more difficult. I know I have the point 0, 0. I know I have the point 4, 1. But which of those things be in between? Now, what you can do, if you like, is look at it and see like, oh, well, that looks like 1/4 and 1/2 and 3/4. Or you could plug it in. So let's see what it would look like if you plugged it in. You would say, I'm going to plug in 1, f of 1 equals 1/4 times 1. Well, 1/4 times 1 is 1/4. You could say, now I'm going to plug in 2, and 1/4 times 2 is 2/4, or 1/2. You could say, I'm going to plug in 3. 1/4 times 3 is 3/4. And you could plug in -1, f of -1 equals 1/4 times -1, or -1/4. And plug that there. You could do that. Or another option, and what I like about this is that there is no right way to do this. Another option is to think about this 1/4, meaning I'm going to add 1/4 as I move along my table. And does that work too? Does 0 plus 1/4 equal 1/4? Yeah. Does 1/4 plus 1/4 equal 1/2? Yeah. And does 1/2 plus 1/4 equal 3/4? Yes. Ooh, I just noticed I made a mistake. I need a negative right there. I had it right there, but I need it right there. See, everybody makes mistakes. Does -1/4 plus 1/4 equal 0? It does. And so what is nice about this way of thinking about functions is that you get to catch your mistakes that you make, if you make them. Okay, let's try one more example. This time we have a table, and you are going to determine the graph and the equation. Your choice. How are you going to do it? Maybe you make a prediction about what M and B are just by looking at the table. You find M by looking at what's happening from one number to the next. You find B by looking here. Or maybe you're more comfortable graphing it first. -1, 0, 0, -2, 1, -4, 2, -6, 3, -8, and 4, -10. Maybe for you, seeing the y-intercept be -2 graphically is more comfortable for you. Maybe for you, why am I so bad at drawing that in? Maybe for you, finding the slope graphically is nicer. Maybe you like to go, oh, I'm going down 2 and to the right 1, down 2 and to the right 1. Maybe that feels better for you than going, oh, I'm subtracting 2 each time. Maybe it's the reverse. I don't know. But did you get the slope was negative 2? And the y-intercept is negative 2? Whoa. Y equals negative 2x minus 2.